So the Icmp protocol, or Internet Control Message Protocol, is a protocol that we use to provide information to us. It reports errors to us. It lets us know if something is reachable. This is something that's documented in RFC 792, and most of us recognize Icmp as what we use to ping a device. And so, very simply put, we open up a command line, we type in the word ping, and then the IP address or the name of a device, and Icmp is going to go out and then reply back and let us know if it's unreachable. And this is done through Icmp message types. And in a moment, we're going to look at the types and the codes. So the two messages that are generally sent, or the ones that you want to see, are the echo request when you ping somebody, and an echo reply when they respond back. And now these Icmp codes can be used to let us know that a destination is unreachable, a host is unreachable, something to that nature. Now, as far as being a security analyst, the reason it's important to understand Icmp is because there are attacks that use Icmp. For example, Icmp doesn't necessarily expect to see a large data payload. They're generally real small messages. So whenever we see an Icmp message and it's got a big payload, we should be suspicious. Also, if we send out an echo request, we should get an echo reply. We shouldn't get an unsolicited echo reply out of the blue. And also, if we're seeing a number of echo request and reply packets that have big payloads, or if there's an imbalance in the echo request and reply numbers, it's really just a good indicator that something odd is happening on the network. Maybe data is being tunneled using Icmp or something to that nature. The RFC does allow for tunneling to occur with Icmp. So we don't have to have a specific length of the data in an echo request or an echo reply message. So people can put more data in there. It's not normal for us to see that kind of thing. Now, this is a look at the Icmp header. If we were to look in the IP header, the protocol identifier would be protocol number 1. Now, following that IP header, we're going to have the Icmp header. In that header, we're going to have, as you can see here, the type, the code, and a checksum. And then beyond that, we'll see some data that will be some variable length. So as far as these type codes go, let's take a look at these type codes. So the type value is a numeric value. So a type 0 would indicate that this is an echo reply, and the code would be a 0. So again, looking at the header, the type and the code, these values are going to be used together to determine what's going on. So let's say we were to ping somebody. We would send an echo request. Now, using this table, the echo request type would be 8 and the code would be 0. If we were to capture a packet and it were Icmp packet with a type 8 code 0, we know that is somebody requesting a reply back, somebody pinging a device. Now, we would expect to see in return an Icmp message with type 0, code 0, an echo reply. Now, there are occasions when we are going to get a message back and it is going to indicate that the destination is unreachable. Again, this is going to be a value that is provided by a type code, and that type is going to be type number 3, and the code will vary. A code of 0 would indicate the network is unreachable. A code of 1 would indicate the host is unreachable. A code of 2 would indicate the protocol is unreachable. 3 would indicate the port is unreachable. And a 4 would be that fragmentation is needed, and there's a bit in the header that is toggled that says don't fragment this particular packet. So we couldn't fragment it. Now, a network unreachable type code is something that would come back from a router. A host unreachable, come back from a default gateway, come back from a router. Port unreachable and protocol unreachable will often come back from the host itself. So let's say you're trying to connect to a web server, and let's say the IP address of the web server is reachable. So you can get there, but the service is not running. In that case, you'll get a message back that says port unreachable, and that's simply because the port is not listening. The server software is not running. Now, most of the time when we get a destination unreachable, it's usually because whatever the host address is that we've specified, it may be a non-existent address and it's just not available. In some cases, though, which is usually less frequent than just the host not being there, the router doesn't have a route to that destination, and that could indicate routing issues. So we want to watch for those 4 basic types of destination unreachable messages. We want to watch for the network unreachable, host unreachable, protocol unreachable, and port unreachable. And that will help us to identify where the issue is. And again, from a security analyst perspective, if we are seeing our network all of a sudden reporting that a host is unreachable or that a network is unreachable, then we might have some type of attack against our routing domain. We could have an attack on our physical domain or something to that nature.